So, a little bit of everything except no relative velocity. Number 1 said this: describe the position of A and B using 0 as a reference point. This was getting us to the notion of displacement, which was so long ago that this became tougher than it should have been. Here's what I mean. I would say that position A is... did I tell you each space was 1 meter? No, so I'm not going to put units. If you put some units, that's fine. You don't have to have a positive. You could have also said 3 to the right, 3 east. All of those would be acceptable. Position B, how could I describe that using 0 as a reference point? -3. And then it says, what's the distance between them? What is the distance between them? Okay. 2 marks, how does that work? You know what? I'm probably going to give you a half mark for that, a half mark for that, and 1 mark for that. Remember the difference between distance and displacement. Look up. If I start here, go here, and come back to there, what's my distance that I've traveled? 12. What's my displacement? 0. Okay? Define scalar. Define vector. We'll talk about giving an example. What else did you say for define scalar? Call it out and I'll tell you if I'll accept that as a half mark. Anybody say something different? So scalars have magnitude only. If you said size, yeah, but magnitude sounds much more scientific and physicsy. Vectors have both magnitude, size, and direction. So that gets you a half mark for each of those. And then it says, give an example. Okay, can you give me some scalars? Time, that gets you a half mark. Half mark for saying magnitude only, half mark for saying time. Anybody else come up with other scalars? Speed. Distance. That's it for this unit, but mass is a scalar. What's your mass? There's no directional component. It's just how many atoms are in you, right? Work, energy, voltage, torque is a vector. Well, anyways, vectors. Give me a vector. Velocity. Wonder how I can remember that velocity is a vector. If I was a good teacher, I'd have an easy way to remember that velocity is a vector. Good morning, my friend. No dice for you. You're just going to come see me. Excellent. Did anybody say any other vectors? Acceleration is a vector. Do you know how I know? What's the acceleration due to gravity? Did you say negative? There's your directional component. So acceleration is a vector. Displacement is a vector. Force, momentum, electric field, magnetic field, other stuff that you'll see down the pipe. Can you get the quiz out? Yes? Okay. Define displacement. What'd you say? And I'll take various, but if I'm going to define displacement, usually I say it's this. Change in position. That's the difference between your displacement is, okay, how far have you moved from your starting point? Don't care about how you got there, just care about where you are. Did anybody say anything else? Yep.
Distance, but with a frame of reference or direction.
Sure, I'll give you that. I'll give you that, but technically it's wrong because if you're zigzagging back and forth, it's not going to be the same magnitude as the distance if you, but I know what you got, we're trying to get across, but a physics nerd would actually quibble with that, but yeah, I'll live with that. Mine's shorter. 3 words. Anybody else? No one? Okay. What'd you say?
Starting somewhere and ending at a different point.
No, because you can also end up where you started from, right? Sorry. What'd you say?
Starting versus ending position.
Sure, I'll give you that. A little sloppy, but sure. Mine's shorter. Okay, now we're getting into some calculations here. They're being a little sneaky. They want the average speed in meters per second and kilometers per hour. Show work. Okay. They want you to find speed. Now, this was at the very, very beginning when we weren't dealing with acceleration yet. So, A is 0. T is 9.8. D is 100. They want that. You're done. The equation that I would actually use would be Kyle, do you notice I didn't put an I right there? Although that's technically the equation. Why didn't I put an I right there? What's my acceleration? Because they didn't mention any acceleration at all, which means this would cancel. It also means VI is VF is VF. In fact, when it says find the average speed, this is V average. How would I get the V by itself, folks? Divide by T, right? It's going to be 100 divided by 9.8. 10.2. Technically, I should go to 2 sig figs and say 10 point, but I'll go 10.2 meters per second. So right now, if I see anything resembling dV, actually, you know what? I'll say this. If I see anything resembling that equation, that gets you 1 mark. That gets you 1 mark. But we're not done. What else did they want? Okay, how do I go from meters per second to kilometers per hour? You know what? It's got something to do with the 3.6. And Noah, on your test, I guarantee you there's going to be a couple of questions where I give you the speeds or the velocities in kilometers per hour, and you'll need to convert to meters per second. And there will be at least one question where I say, oh, give me the answer in kilometers per hour, because that is car speed. It's what you're familiar with. I'm not big on, for the rest of the year, though, I'll almost always just give things in meters per second. But in this unit in particular, it's worth knowing roughly, hey, 10 meters per second. Is that walking speed, running speed, driving speed, or 10 meters per second? I think we looked at that chart last day. We said that was Usain Bolt running speed, right? Anyways, how do I go to kilometers per hour from meters per second? Times by 3.6 or divide by 3.6? 36.7 kilometers per hour. Here's how else I know, okay? 10 meters per second, that's Usain Bolt's running speed, okay? It's either going to be a road speed of 2.8 kilometers. You know what? He runs faster than 3 kilometers per hour. It's times. He's running, you know what? He could almost get ticketed in a school zone. Okay? He's that fast. So it's going to be, what did I say it was? 36.7 kilometers per hour, and that gets you 1 mark. So there's your 3 marks for this, okay? Now, there's various ranges of skill right now on this stuff. On the test, I hope what you're seeing, though, Nick, is don't leave anything blank. Hey, Dueck gives me a mark if I can just figure out what equation we're using. Yeah, I do. How far will I run? You know what? I'm going to use this again. What happened to the plus a half AT squared? I'm assuming A is 0. And that's why, by the way, I'm carefully saying average speed. That really you can use. In fact, I think I have that on your yellow formula sheet. So it's going to be 6.3 times 45. Uh, 283.5, is that right? Yep. I would go 1 mark if I saw that, 1 mark if I saw that. By the way, how many sig figs should this answer be technically? Technically, am I going to take marks off for sig figs? No. Will I continue to emphasize it? Yes. You know what? Number 7 says how long? I'm still going to use d equals vt plus a half at. So what happened to the half at squared? No way. How would I get the question, Thomas?
I wrote down the right answer and then erased it and wrote another one.
Boy, I'd feel silly. Don't do that on the test, right?
Yeah.
How would I get the t by itself, Thomas?
Divide by 2.
Can you say it with authority and confidence in your voice? Not like your guess. Here's what I want to hear. Divide by v.
Divide by v.
Divide by v. V. Yeah, okay, good. So t is going to be what over what?
D over v.
More specific in this case, what over what?
12.3 over
Yeah.
2.3.
By the way, how did you figure out that it was the 12.3? Are you cluing in? It's really worth memorizing units, folks. And as much as I hate memorizing some stuff, if you memorize what units go with what things, it really cuts down on mistakes. 12.3 divided by 2.3. It'll take you 5 seconds to run 12. Wow, that's slow. Oh, 2.3 meters per second. You know what? Look up. All of you can run faster than that, I think. Myself perhaps excluded because I'm injured, but yeah, 5.3. 5.3 what? Seconds. Colin, what does the slope of a position versus time graph represent?
Velocity.
So, for each of these on the next page, these are all d position versus t time graphs. So for each of these, the slope is what, Colin?
Velocity.
So if it wants the average velocity of the car for each part of the trip, you know what? I see 1, 2, 3. Oh, 3 marks, 3 sections. In fact, you know what? Why don't I be really clever and I'll call them section A, B, and C. So the velocity for section A, how do I find the slope? Slope is what over what? It's the rise over the run. The first line has a rise of 5 and a run of 1. You know what? It's got an average velocity of 5 meters per second, 1 mark. Why did I do this for part B without even thinking about it? Why did I skip ahead and put a negative? It's downhill. I wanted to make sure I don't forget that. You're slowing, sorry, not slowing down. You're going backwards. Okay. What's the rise? Well, I'm 5 high here. I'm 4 high here. The rise is 1. What's the run? I'm 1. I'm 3. The run is 2. Negative 0.5 meters per second. And yes, if you left it as negative a half, that's fine too. C. You know what? It's also negative. What's the rise? I'm 4 high here. I'm 0 high here. The rise is 4, technically negative 4, because you're going down. What's the run? I'm at 3. I'm at 5. The run is 2. I can do this in my head. Negative 2 meters per second. Is that right? Yes? 1 mark for each of those. Number 10, consider the following velocity versus velocity versus time. What's the slope of a velocity versus time graph? What's the slope, Colin, of a position versus time, or distance versus time, or displacement versus time graph? Velocity. What's the slope of a velocity versus time graph? Acceleration. Did you memorize that? You can, or you can realize it's rise over run, it's meters per second, or meters per second squared. That's acceleration. If you had a good physics teacher, he might have suggested that it was worth memorizing units. Okay, it says, describe the motion. You know what? There is 3 parts here. What can you tell me is happening in part A? Speeding up. Sure, I'll take that. What's a fancy word for speeding up? I take that. From rest, because you're initially going 0 meters per second. Speeding up from 0 to 9 meters per second. What's happening in part B? Ah, you used the physics term, Spence. You made my little math nerd heart go pitter-pat. Constant speed. What's happening here? Slowing down. In fact, I could actually figure out the acceleration if I really wanted to. What's the rise for section A? 9. What's the run? 5. If you really wanted to impress me, you could say that the acceleration is 1.8 meters per second squared. I didn't ask for that, but I would have no problem asking for that on a test if I gave you good numbers. And acceleration is 0, and acceleration is negative. You know what? I think it's going to be, again, rise of 9, run of 5. I think I made this trip kind of symmetrical when I was drawing this. Okay, so for 2 marks, Mr. Dueck, how are you going to give 2 marks? Half mark for saying speeding up, 1 whole mark for constant speed, half mark for saying that. Really, it should be worth 3 marks, and I keep forgetting to change it. I like number 11, I like number 11, I like number 11. Number 11 is a nice question. What can you tell me, what kind of a graph is graph A? What are we comparing? What versus what? Position versus time, or distance versus time, or displacement? Well, it's not distance because I see a vector sign on the displacement versus time. Where does velocity appear on this graph then? Okay, what can you tell me about the slope? Positive or negative? Constant or changing? So what I would look for 1 mark is a horizontal line above the x-axis. Now, I didn't put any numbers. You could put it up there. I'd have to accept that. I don't know. But I'm telling you, if you were to graph the velocity, it's a constant speed. And it's positive, so it's above the x-axis. What if, by the way, it had done that? Right? Negative slope below the x-axis somewhere. Still constant speed. I'm trying to think about other ways I could ask this question. Oh, B. Okay. What can you tell me about graph B? So how big is the velocity as a number? I'd look for a line like that. 1 mark. C. Ooh. Constant speed? What can you tell me about the speed, the slope? Is it getting steeper or shallower? Steeper. What can you tell me about the velocity? Is it getting bigger or smaller? Bigger. You know what? I think it'd be something like this. Again, Kyle, you could have gone steeper or you could have gone shallower, but I'm telling you, the velocity is increasing. Something like that. 1 mark. Can you give yourself a score out of apparently 21? Whoop. the spinning wheel of death. That's not good. There we go. Pause the video. So just for posterity then, your homework is going to be for Wednesday, take home quiz number, I think I called it number 7. For my numbering's a little wonky, I know. Finish off solving acceleration problems. Finish off relative velocity. Study, what did I call it actually? I think I called it review assignment or something like that. Velocity acceleration unit review, that's what I called it. Velocity and acceleration unit review due Friday. Test next week, Friday.